Strings are among the most widely used types in C# and .NET. The official definition of a string in the .NET documentation is as follows. A string represents text as a sequence of UTF-16 code units. While concise and precise, that's a potentially confusing definition. More simply stated, strings represent textual information such as a username or hostname. Strings are, in essence, a sequence of characters. Let's go back a few steps and consider the written word. If I write the Latin letters H, E, L, L, and O in a single sequence, you'll recognize this pattern as a representation of the English word hello. We use specific symbols to represent the letters of the English alphabet. When combined, these letters form words, which we can then assemble into sentences and paragraphs. Of course, there are many other alphabets worldwide, each with their own letters, or more precisely, characters. In general, a character is any symbol that can appear in writing. So this includes the letters of the various alphabets, but also punctuation marks, digits, and even white space. Conceptually, .NET treats text in a somewhat similar way. For example, we can declare and initialize a string as follows. On screen, this is not unlike the handwritten version of the word. It includes the characters H, E, L, L, and O. Of course, these letters must be stored in their original sequence to maintain their meaning. Internally, a string is very much like an array of characters stored in order. Strings are one of the built-in types available in C# and are sometimes misclassed as a primitive type. That distinction is not too critical, but it is important to realize that their design has been optimized for maximum performance because strings are a common data type used in every application. Strings are a reference type and use memory from the managed heap. Longer strings require more characters and therefore occupy more memory. Because they are reference types, strings are eligible for garbage collection once other objects no longer reference them. Although a reference type, strings have some semantics more familiar to the primitive built-in value types like integers. The most obvious is that two string variables can refer to two different string instances on the heap, but will be considered equal if they contain the same sequence of characters. The string type overrides the equals method and the equality operators to implement this behavior, which differs from the default equality check for most other reference types. The Common Language Runtime, or the CLR for short, executes our compiled C# code, and it includes special treatment for strings. Some code that defines strings is written in managed C# code, but other parts are written in unmanaged code at a lower level, including support for fast allocation of the memory needed for string instances.